All right, we are live. Hey, how we doing? Pre-cal class, good to see you. Those of you who would just follow me on YouTube because you feel like it, good to see you right now. Some of you right now can see three of me. You just see behind me. It's okay. There's only one of me, so we're all good. Okay, we're gonna get questions answered. Again, we're talking over today zeros of a polynomial, logistics of that, and we'll go straight into it. Remember the sections. Sections are over 2.5, 2.6, and 2.7 there. And if you have any other questions, again, you can always either email me or just contact me and or come in the morning. All right, let's get it underway. Let's get it started. All right. Wow, that was pretty cool. All right, let's get this, screen share it. What's cool is y'all know kind of how it's done now. Behind the scenes tour. It's good stuff.
Right until it stopped showing, right? Just like CNN.
That's right, just like CNN.
This is not like CNN.
This is
No.
like
Yeah, it is.
No,
Absolutely.
that's
It's everything. That's true. That's true. All right.
like
We have a live studio audience today. Some people call me Jimmy Fallon.
Jerry.
Not Jerry Springer. Not Jerry Springer, although, never mind, we won't go there. All right. We are on YouTube here. All right. So, with that being said, my tablet's about ready to go out, so we're going to ask questions. So we don't have a lot of lag time, someone give me a question. We're going to talk through sections 1 through 5. So if you have numbers 1 to 5. So if you have any questions over that, go ahead, throw it out to our YouTube viewers there.
Only numbers 1 through 5.
Yeah, right now we'll focus on 1 through 5, and then we'll rock and roll from there.
Number 2.
What'd you say, Toots?
2.
Number 2. Number 2. Let's take a look at it. Number 2 states find all the zeros of the function, and that's pretty much it. Gives you a function here, gives you a polynomial, and it just says, hey, tell me what all the zeros are. Now, in a normal world, if we had something that was just like so, and I'll kind of write this down, x to the 4th plus 10x cubed minus 10x squared plus 5x minus 66. If you had a polynomial like this, what you could do if you didn't have a calculator is you could just list out the possible zeros. Now, if you listed the possible zeros out, that'd be kind of a bear, right? Because what you would have now is if you did P over Q, what you would have is if Q is 1 and where P is negative 66, we'd have 66 over 1 plus or minus 1, 2, 3, and so on and so forth, right? We'd have all of them, all over plus or minus 1. Now, that's quite a few, and you could solve it that way, but that's a lot that you'd try to test with synthetic division. So is there an easier way? Does anyone know of an easier way we could kind of figure out some of these zeros without having to plug every one of them into synthetic?
Go to graph.
Bingo. Look at the section that it says there. It says on the top, this is a calculator question. Now, when I give one like this to you, like look at number 10. Number 10 is one where you'd have to do it without a calculator, but your possibilities are a lot less than what it would be on number 2 or what it would be like on number 6. So the best thing that I can do is just tell you to go and graph it on your calculator and find what the zeros are by what your calculator says. So again, if I were you, if you go to it, I'd plug this bad boy in. Plug and chug. Hashtag plug and chug. Yep. All right, so if we kind of put that down there, x to the 4th plus 10x to the 3rd minus 10x squared plus 5x minus 66. If we were to graph that there, when we graphed it, what is the first thing? If you don't see it within your window, what's the first thing that you can do? So I put this into y equals and I've graphed it and all that. What's first thing we do? I always go to Zoom Standard first, okay? Zoom Standard, that gives you to a basic 10 by 10 graph right there. Sam?
How do we get there?
Oh, if you go, great question. On the top, there should be a button up on the top of the top 5 there that states Zoom.
Gotcha.
Got me? And then right below there, I forget what number it is.
Not fit, but
Yeah, it should say Zoom STND or something. Okay, and then right there when you click on that, it should give you a 10 by 10. Now, 9 times out of 10, you're going to get it within your window. But for those times that you don't, what you could do then is go to where? What's the second one? Yeah, Zoom Fit. So if you go to Zoom Fit there, that would be, again, another way you could kind of go to it. And then my third one would be what? I would then go to zoom out as much as I can if I needed to do so, okay? And again, what that does for me, that allows me to then take those 3 and be able to see where my zeros are at. Now, how do I find where my zeros are at? Do I need to go over that?
Second trace.
You can go to second trace, right? And then it says right there zeros, right? Now, let's say, and again, the graph looks something, when you found it, would look something like this. And I know I'm going to butcher it, but it looks something like that. And so what we're trying to do is find where these zeros are. And to do that, make sure that when you have left bound, it's to the left of that 0, and right bound should be to the right of that 0. And then the guess, obviously, put it as close as possible to it. And so if it comes back and says, hey, no change in sign, that means you probably didn't do a left bound and a right bound correctly. So when you did that, you'd find where your zeros are at and then kind of go from there, all right? Are there any questions on how I would graph it or how I determine where my x-intercepts are, where my zeros are? All right, good. Number 1, what would 1 be? Anyone find one?
X plus 11. Or X equals negative 11.
Yeah, I would say x equals negative 11. So if 1 equals x equals negative 11, we're good to go. What's another one?
X equals 2.
X equals 2, good. So we've got 2 different zeros that we know of that we didn't even have to guess on. We just know from that those 2 are zeros. So what could I do in order to find, well, first off, how many zeros can I have or will I have? There'll be 4, right? That doesn't mean it crosses the x-axis 4 times, but it could go up to 4 times. So we know we have 2. To find the other 2, what could we do to find the other 2 there?
Could we plug it in synthetic?
Exactly. Good, Chris. So I'm going to plug 1 in, like 2 of 2's there. Then I'll put the numbers down on the side. So 1, 10, negative 10, 5, and negative 66. All right, we'll put that there. Bring down the 1. Again, multiply. Am I going too quick right now? Is anyone still following me? Everyone still? Is everyone? Yes. Those of you at home who just enjoy watching math problems, are you okay? If you are not, I am sorry. All right.
See a therapist. It amazes me that synthetic works out.
1, 2, 12, 24. Make sure your signs are right, because sometimes, like what I just did, sometimes I get my signs wrong a little bit. So just make sure on that. If you're at home, 29, there we go. Now we've got, should be 28 here. Good night. I'm messing that up. All right, 66, and now this should be 0. So now I should have 1, 12, 14, 33, and 0, or x cubed plus 12x squared plus 14x plus 33. So to do it again, what could I do? Well, Chris probably, yep, plug in negative 11 now. So we're going to plug in negative 11 to, again, don't do it to the original. Do it to the one that you already reduced. A lot of people messed up on that on the quiz. And so now we're underway here. I got a 33, and then we have a 0 here. And again, the whole evidence that you have a 0 is the 0 where? How do I know in synthetic if it's a 0?
Oh,
If my remainder is 0, if I do not have a remainder, that tells me I've got a 0. Okay. So 2 and negative 11 are there. Now we have the rest of it, which is x squared plus x plus 3 equals 0. Well, what could I do to solve for the other zeros there? Yeah, if I could factor it, go ahead. Can I factor it? No. Okay. So what could I do? Go straight to my quadratic formula. Okay. For those of you who follow me on my rap channel, Coach B Shizzy, you can see my one called the quad solve. You can learn that rap there. Okay. All right. All right. So right here, do I need to go any further with that, with the quadratic? All good neighborhood? All right. Sweet. All right, let's go to the next one. Is it okay if I erase this? Anyone? Speak now. All right. Some of us are a little slower than others at home. It's okay.
I'm in.
For those of you at home who think that I'm going too quick, there is such thing as a pause button. You can pause me.
I don't believe it. There's also a mute button. Oh.
There's also something called get out of my room right now.
Okay,
You know?
bye.
Caleb
Yeah.
would love to do
That's right.
It's currently snowing.
Yeah.
Those of you who don't know, it's snowing outside and Caleb ran.
Yes.
Oh, that is
Screening
also-
anarchy. All right, next one. Numbers 1 to 5. We did number 2. Is there another one that you say, Coach, could you do from numbers 1 to 5? Could you do this one? All right. Anybody 1 to 5?
For number 3, I was
Yes.
It says you must provide both the x and y value for each of the holes.
Yeah, could we do that one? Yeah, let's do that. So, again, f of x equals x cubed plus 2x squared. This is number 3 here.
Cool.
Is it just asked for a hole there, Catherine?
And that's for find all the asymptotes and all holes, and then it says you must provide both the x and y value.
Okay, so my first thing I do, if you remember, was off that sheet I gave you, or the thing you created, was we want to factor, right? So we get x out to get x squared plus 2x minus 15 all over, and then when I factor the bottom, what'd you get?
I got x plus 3, x plus 5.
Good. And then at the top, I think we could factor this out, which would be what there?
X plus 5, X minus 3.
Good. Okay, so if I, again, did the bottom and the top, I'd get x plus 5, x minus 3. Okay? And then again, I'll put that on the bottom here too. All right, so real quick, we'll kind of go through all the ones we have talked about. So we have our HA, we have our VA, we've got our x-intercepts, y-intercept, and then I've got the holes there. Okay? All right, so what are my vertical asymptotes going to be?
It's just going to be negative.
Just -3, right? Good. So we know at our vertical, it'll be at x equals -3. Okay? Also, these will cancel. So what do we know about our hole there?
-5.
It's at -5. Good. Okay? Now we know that that's our x. The question is how do I find my y within my hole? Does anyone have an idea on how I could find what the y value is of the hole?
0 for every all the X's.
0.
You're saying to find our y-intercept?
You plug in that number in X.
Good. You plug it in, but don't plug it in to the original, right? You want to plug it into the values with the simplified version. Because if you plugged it in without the simplified, it would get you undefined, right? Because you'd have a 0 on the bottom. So if I plug that -5 back into my x here, to find my y value, I'd get -5 times -5 minus 3, which would be -8, all over -5 plus 3, which would be -2. So -5 times -8 would be 40. 40 divided by -2 would be -20. And so that's how you would find what the y value is of your hole. Does that make sense, Catherine?
Yeah.
The simplified version.
You just plug in -5 for all the X's.
Correct. The simplified version, right? Because if you plugged it into the bottom, Chris, you'd get right here, -5 plus 5 would be 0. You get a 0 on the bottom. It would be undefined, right? So we want to make sure that you have to plug it in, but plug it into the simplified version, okay? The horizontal asymptote would be what in this case?
None.
None.
Why do you say that?
Because the exponent on the top. is
Greater
higher.
degree on the top.
Great, good. Greater degree on the top than the bottom. Although, what do you see on the top?
Max.
X to the what?
1.
X to the third, right? Okay. What do you see on the bottom? What do you see? What's the problem with that? What does that mean? That's exactly right.
Is that a rule?
That's a rule. If you have one greater on the top than the bottom, right,
You got a slant.
then you have a slant asymptote there. So what are you going to have to do to solve for that slant asymptote?
Oh, no.
Divide, exactly. Okay, divide. How about this? Before I divide, let me go into the x-intercept, y-intercept. If it's the x-intercept, you plug 0 in for?
We don't have to
Why?
do that.
Oh, you don't have to find that?
Really?
Just run with
Could
it.
we
Yeah.
find it for fun?
Oh, yeah.
Yeah, so if I did that, if I tried to find the y-intercepts, I plug 0 in for x, right? So if I did that there, I'd get 0 times -3, which would be 0, right? On the top, all over 0 plus 3, which is 3. So 0 over a number would be what? 0. So my y-intercept would be 0, 0. And the easy thing to do for the x-intercept is plug 0 in for y. So if you did that, you get 0 equals x times x minus 3 all over x plus 3. What can I do with the denominator if it's equal to 0? I can just throw it out, right? Because if I multiply by x plus 3 on both sides, I'll get 0. So what are going to be my x-intercepts that makes the top true? 0 and 3. Good. So I'd say 0, 0 and 3, 0. That makes sense there, Sam?
Yes.
Okay. What's a good thing to do? Well, again, also number 3 is use your calculator, right? So technically, you could end up using your calculator to find this as well. That's possible. So again, that's an option as well. But if I could, I'm going to erase this right here. And what I'm going to do is I'm going to kind of, if it erases, there we go. There we go. We're going to divide this bad boy. Get this thing out. Okay. All right. Now, let's divide this out. So we'll get x squared plus 8x plus 15 goes into x cubed plus 2x squared minus 15x plus 0.
Wait,
Okay.
why are you doing that?
Why am I dividing?
Oh.
Because of the slant asymptote. Because of the slant asymptote. Now,
I
what?
really understand those.
Well, remember, if the degree on the top is greater than the degree of the bottom, right? You're going to have no horizontal, right? So I should probably put this right here, none. Nada, nacho cheese.
Anytime there isn't a horizontal because there's too much on the top, there's a chance of a slant asymptote.
Correct. Only when it's one greater on the top than the bottom.
Okay.
Only when you're one greater on the top. That's it.
All right.
Okay? So now, at this point, what times x squared gets me x cubed? Well, we know that's x. So we're going to multiply this out here. Okay? Change the sign. So negative, negative, negative. So I'll get negative 6x squared minus 30x plus 0. So what times x squared gets me negative 6x squared?
-6.
Negative 6. And then we multiply out, right? But do I really need to go any further here?
No, you got your towel.
Yeah, because the remainder, does that make a difference? No, it doesn't. So the only thing that I care about is my slant asymptote, which would be y equals x minus 6, and we are good to go. Okay?
You don't have a horizontal.
No horizontal. You cannot have both. I don't want to ever say never, but with what we're doing, we'll never have both because the top is greater than the bottom, therefore there is no horizontal. And it's only, the only time we use slant is when it's one greater on the top than the bottom. Okay?
Got it.
We don't care about the remainder.
The remainder doesn't matter because can you have a remainder? I mean, how would you graph that? Like say it's x minus 6 minus 50 over whatever. If we drop the remainder, it's only the part that is what we just solve for. The part before that remainder. What's there?
Okay.
Does that make sense?
Yeah.
Questions? We're good? That's a doozy, isn't it? A little bit of a doozy. You need to make sure you're ready for that, okay? Again, if you get everything right, you forget to do slant asymptote, again, I'm going to give you some of that problem back. But if you don't, again, don't get overwhelmed in it. At least try to tackle it. At least go after it, persevere, try to get that done, all right? All right. Any other ones from 1 to 5?
Could you real quick go through 4?
Absolutely. Okay, so real quick, if we were, and this is actually a fast one. I was talking over with a couple people about this one in other classes and in this class as well. If 2 and negative 11 are zeros, okay, that's a given. We have a 5th degree polynomial, x to the 5th. It could be anything, but the highest degree is to the 5th. Is it possible for 1 minus 3i, so these are the ones that are given, right? But is it possible, these are possible ones, is it possible to have zeros that are 1 minus 3i and 5i? Any ideas? Is it possible? No, why? Why, Aaron? Bingo, exactly. Okay? So if you have 1 minus 3i, because of that imaginary number there, because it's a complex number, by rule, remember, by rule of conjugate of zeros, we must have 1 plus 3i. And if we have 5i, we also have to have negative 5i. Okay? Well, if that's possible, that means how many zeros do I have right now? 6 with a 5th degree, right? Can you have that? You see how you can't? Because it's greater than what our degree is, and we can't possibly have that. All right? That's a good question. That's a really good question. All right. 1 through 5. Any other ones? All right. 6 to 10. 6 to 10. Number 6, do we understand number 6? It's pretty much the same thing as number 2. Y'all understand that? Same process as number 2. You'd execute that the same way. Graph it, list the zeros, use synthetic to then simplify to solve for what the other zeros are, okay? Any others from like 7 to 10? These, again, are now no calculator section. 7 to 10?
5.
Go back to 5? Yeah, we could do that.
For the domain, is that just like finding the x values, or is that just going swinging out? Is that like x toward infinity or something?
Yeah, so you could have 2 ways that you can write this here, Chris. So, what's the only thing that's going to eliminate, or not eliminate, but stop our domain? There's only one thing that can stop our domain from left to right.
Asymptote.
An asymptote. Which one?
The vertical.
Vertical, right? Because we're talking x here, right? Now, range would be different, but when we're talking about our domain, from left to right is how far we can go, right? So it's from negative infinity to positive infinity when it's a rational expression. The only time when it's not is when we have a vertical asymptote that creates, remember, the crack in the graph, and that approaches it, and that, it's infinity. Sorry, I forgot I was on YouTube. As we approach that. Does that make sense?
Mm-hmm.
So as we look at this, what's our vertical asymptote?
It looks like 0 and negative 4.
Okay, 0, well, I don't think 0 is, right? Because this is not a variable. So I think it's just negative 4. Just negative 4 there. Now, what I would do as I get to this is I would take this, not that it really matters, I would take that negative out. So I'd have negative up on top, and I'm left with x squared plus 2x minus 12. And as I solve for that, I don't think there's any way I could factor that. So, I mean, it doesn't matter either way. My whole thing is there is a possibility where that vertical asymptote could be a hole, right? But it's still, the domain, is a domain restricted? Whether it's a hole or a vertical asymptote, the thing is it's still restricted, right? Still can't be there. So I'll allow you to do 2 things. You can put from negative infinity to negative 4, union negative 4 to infinity. All right, I'll give you that. Or if you desire, you could put for all of x cannot be equal to what?
Ooh.
Negative 4. I'll give you either of those 2. That's fine. Okay? 2 different ways of putting it, but I'll give it either way. I think in the book it gave the bottom one. I taught the top one. Either way is right. Okay? Set builder or interval notation there. Well, set builder would be different, but yeah, well, either
That's
one.
what I do.
Either one.
I build sets.
That's true.
This is true.
All right, Chris, that makes sense here?
Yes.
All right, let's look at number 10. Find all the zeros of the function. It's number 10. We'll go to number 10.
What accent are you going for?
I'm Sweden.
Math teacher.
Swedish.
I'm Sweden.
Shaja. Organ. Just go straight up Swedish chef.
I'd love people that don't know us to be able to watch this. In fact, they do. They'll leave comments,
Totally not.
No one leaves comments.
No, you're right. But
Subscribe.
Yeah, that's
below.
all right. So right here, we've got our Q and P. We want to go P over Q. So our P is obviously 2. Again, we'll drop the sign because we'll do plus or minus with both. And with the Q, we'll put 3. So on P, we'll do plus or minus 1, plus or minus 2, where the Q would be plus or minus 1 and plus or minus 3. Okay? Now, the big thing that a lot of people mess up on is to take the 1 to both. So it should be 1 plus or minus 1, and plus or minus 2, because it goes to both there. And then the next one would be plus or minus 1/3 and plus or minus 2/3. Okay? All right? We're good to go? Does anyone disagree with this? Speak now or forever hold your peace. Sweet. All right. So what zero could we choose to plug in? Well, first of all, how many zeros are we looking for?
A lot.
We're going to have 4, right? We're going to have 4. Does that mean all 4 are going to be from here? No, we've talked about what imaginary numbers, right? How if we have a 3i, we have to have a negative 3i. So that could be incorporated there as well. So what we want to do is just try to test them out, okay? So we'll roll the dice here, try to pull it out there. Anybody do number 10? Want to give me a good lucky guess there? Oh, there you go. -2. So we'll plug -2 in. We'll have 3, -8, 6, 3, and -2.
Is it 8 or negative?
Say that again.
Is it 8 or negative?
I think is it -8? Oh, it is +8. You know, that's why students are there to help me, help the teacher out. Give me a little assist, okay?
Just
Nice
let
job.
us know when
Nice
you-
job, Toots.
Shout out.
Yeah, give a little shout out to Toots out there in YouTube land. All right, so -2 and 3 get -6. Obviously, just keep combining together. 2 times -2 is -4. 2 got -4 here, -1 and 2. So that's exactly right now. We've got now 3x to the third plus 2x squared plus 2x minus 1. Now, in knowing that there's a -2 here, we can then use whatever our answer was to then use synthetic again. So we'll bring down 3, 2, 2, -1. So let's try this one more time. Any other guesses out there? We got -2, 1/3, okay? So we'll try 1/3. Again, bring down that 3. 3 times 1/3 is 1. Add it together. Do the old add action. 3 times 1/3. Get 1, 3, and 1 again. And again, 1 and -1 would be 0. For those of you who are out in YouTube world there that are watching me, Coach Jay Shizzle, remember that if anytime I have a 0, 0 as a remainder tells me that it's a 0 of my polynomial. If I don't have a 0 as my remainder, we know that it cannot be that 0 there. You might want to try again on that, okay? All right, we just guessed correctly, or I have students that are very bright that could help me out with that. That helps too, all right? So we know it's -2 and 1/3. What could I do on the last one? Well, I know a lot of you at home are like Dora Explorer yelling at the screen. Really, what we could do,
You need a mouse.
You gotta pause.
I don't need a map right now. I don't need help. But what I could do is actually go to it and use what? Instead of trying to plug any other ones in.
You gotta pause. Quadratic.
We all gotta yell together.
Nicely done, Chris. Nicely done. Very good. And just like Dora the Explorer, always correct
Can I
there.
s-
Okay?
Can someone swipe my homework, please?
This is true. Yes.
Swipe over. Go ahead and swipe.
Yes. So then we do -b plus or minus square root of b squared minus 4ac all over 2a. And so, yeah, all over 2a with Humpty Dump. What was that? The Pop Goes the Weasel. That's right. Farajaka. What are we doing? We're on YouTube right now. 9 minus 36 now would be -27. So now we've got -3 plus or minus the square root of -27 all over 2a or all over 6. If I simplified the square root, I should get 3i root 3. I'll kind of cross that out, root 3. Since this 3, 3, and 6 can be all divided by 3 there, it's got to be all 3, remember, not just 2 of them, all 3. We then get -1 plus or minus I root 3 all over 2. And what I'll allow you to keep it as is for that. If you divvied it up and said -1 half plus or minus I root 3 all over or over 2, I'm okay with that as well. But again, those would be one would be the plus, one would be the minus, and then these two over there. We know the degree is 4, so we know our work is done, and we are good to go. All right. Questions on that one? That's a tough one. Again, those zeros are ones that you're going to have to keep working on, keep practicing on to really get good at it there. All right. All right, numbers 7 through 10. Any other ones that you see over there that you might need help with? 7 through 10 at all? Number 7 is very similar, that we actually helped you out. All I ask is good Christmas gifts on that for helping you out there. But with 7, it tells you what ones are not zeros. So you can eliminate those when you do your P over Q. So again, that's just a strategy. Number 8, we already kind of discussed there. Remember, 8, will there be a horizontal asymptote? For those of you who are in YouTube land, I'll give this to you. 2x squared plus 2x minus 3 all over x plus 3.
It's a slant.
Probably going to be a slant asymptote, right? Probably going to be a slant because the degree on the top is 1 greater than what the degree of the bottom is.
Why would you say probably it is?
What's that?
Why would you say probably it is?
The only time that it would not be, does anyone know when it wouldn't be? Because I haven't factored the top out.
Oh, okay.
Aaron, was there a slant asymptote on this one? Number 8? There was one. The only time that it wouldn't be, remember, and won't be if you're able to cancel top and bottom out,
Gotcha.
right? Because then if you were to simplify it, now the degree would be 1 on the top. Not going to get to that because don't think we'll come to that. I think we came up 1 on the homework. But again, 1 degree greater on the top than bottom, we know it's slant asymptote, and we're good to go.
Coach, for number 8, did you do the x-intercept?
Yeah, x-intercept, if we were to do that, we plug 0 in, right, for g of x. So it'd be 0 equals 2x squared plus 2x minus 3 all over x plus 3. Do I care about the bottom?
No.
No? I'm gone now. So if I said 0 equal to that, I could now just do quadratic formula, or I could try to factor it out. I haven't tried to factor it out here. If I did a times c, I'd get -6, right?
Yeah, it does.
Does it not? 2x and 2x. What 2 multiplied to -6 add to 2? Yeah, I don't think so, right? So you're going to have to do quadratic formula on that top side to be able to get what that answer is. Do you want me to do that, or are
No,
we?
you don't have to.
We're good to go. Okay. All right. So again, we do the quadratic formula off on that one. All right. All right. Colin, does that make sense? So because the top I can't cancel, or I can't factor it out, right? Because of that, I know right away that if I can't factor it out, I go to quadratic formula on that to be able to solve for what the x-intercepts are. Remember, x-intercepts, you plug 0 in for y. Y-intercepts, you plug 0 in for x. Excellent. All right. All right. Do we know number 9? Pretty good.
Yeah.
We're good there. Okay. All right. Let's look at this. 11. Oh yeah. By the way, those in YouTube world, 15 and 16. Throw those out. Those will not be on the test there. I had a conniption, just forgot, went off the cuff there. If you want to do them because you love math that much, go right ahead.
Oh, okay, good.
Okay.
That's 15 and 16 are the ones. that are
15 and
the same.
16.
Okay.
15 and 16.
Yeah, like I thought something was weird with those. What with the fact we never talked about them?
This is truth. This is truth. 11 to 14. Anyone got 11 to 14 that you look at and you might just want me to do real quick? Would 12 have a slant asymptote?
No.
Good.
Y equals 0.
Good. Y equals 0, right? Because one greater, or it's greater on the bottom than the top. What about 13? Would you have a slant asymptote on 13?
Oh, yes.
No. What's the degree on the top?
Oh, no.
Degree on the bottom?
Squared. It's the same,
So,
right?
so it's the same. What do we do?
A over B.
A over B. Holla out in the hizzy. 1 over 1, you'd get 1 there. So y equals 1 on that. Questions? Questions at all? No other questions. Wow.
How about
Hot seat.
Yeah, hot seat on YouTube. That'd be great.
Oh yeah,
No.
that would be.
No.
Are there any polls for number 12?
And our sanity. No, Caleb.
On number 12,
We talked about this.
There was a very good question.
What's that?
Was there?
Yes.
Oh,
All right. 3x minus 15.
as long as it involves.
All right, so factor the top out. We'll get 3 on the top. We'll be left with x minus 5. All over, x on the outside, be left with x squared minus x minus 20. What can I factor on x squared minus x minus 20? What could I do to factor that?
It would be x minus 5, x plus 4.
Good. So because of that, where do I cancel?
X minus 5.
Good. So I'm going to have a hole at well, actually, I'll put the point here because we talked about that. It'll be at 5 comma. How do I find what the y would be of that?
Plug it in.
Good. And if I did that, I would get 3 over 45. You could correct me if I'm wrong, but I believe so. So we plug 5 in for here. 3 over 5 times 9, which would be 3 over 45. Okay? And in fact, I could actually reduce this to then 1 over 15. So it should be 5 comma 1 over 15 would be my whole. Was that your question?
Yes, sir.
The whole?
Yep.
And then vertical asymptote would be x equals -4 and 0. And horizontal would be y equals 0 because it's greater. The degree is greater on the bottom than the top.
Good deal.
Okay?
So it's 1 over 15 up there.
1 over, when I reduce 3 over 45,
Okay.
I'll get 1 over 15. Yep. Horizontal, again, would be y equals 0 because the degree is greater on the bottom than the top. My vertical would be, again, x equals 0 and -4. Remember that this is okay for, like when I'm talking about horizontal and vertical asymptotes, it's okay to put x equals, y equals. But be careful. If I ask for the x-intercepts, give me the point. Got me? Give me the point. So if I ask for the whole, again, I want a point, an x and y point there. All right? Any other questions?
Yeah, for the y, you plug in the 5 into the simplified version, right? Simplified x's, like for the whole and
For the whole, I plugged 5 back in for the simplified version.
okay.
So that's how I, again, find that y. The 1 over 15 would be 3 over 5 times 5 plus 4.
Okay.
Yep.
Wait, Coach, wouldn't the top, if you did x minus 5, it would be 0, so 3 times 0 is 0.
Yes. So if I plugged in 5 for the top, that's why I have to do it to my simplified version, right?
Right.
Because if you did it to the top and bottom, you'd be right. It'd be 0 over 0.
X minus 5 is no longer there.
Yep.
Yeah.
It's gone like a freight train, gone like yesterday, gone like a bang, bang, gone like a
Like all the good things that are never coming.
she ain't gone.
Stevie, can Steve sing some more?
All right.
No.
To finish up our podcast, Stephen
No.
with the pirate bounty.
Yes.
Pirate bounty.
I could sing when you're evil, but someone might get offended.
All right. No. We want clean versions there, Stephen. This is on YouTube right now. Clean versions.
Please,
Have you
yeah,
seen
the
YouTube
most
videos?
Stevie voice on earth. Right.
Stevie B.
Right.
All right, Stephen.
No.
As we wrap it up, 2 seconds. 2
Thanks
seconds.
to Pirates Bay.
Hey.
Sing it.
Please,
There you
the
go.
Pirates Bay. Hey. Woo.
Anyone else want to give a little shout out in this? Anyone shout out here? Shout out.
Hello to all
Oh,
the.
Nope, Caleb's talking. We might want to stop.
All right.
this.
Well,
Oh, we go.
censored the end of this program.
Well, it has been it's been good to knowing you there, YouTube friends and family. Hope you have a great day and stay classy.
This program is brought to you by viewers like you.